All right. So, a little bit about where the organization that I work for. Jennifer referred to it a little bit. However, I just want to pull up this map here. So we serve 58 different communities across the state, and they're all microgrids. They're very remote. Only one of them can be accessed by road, and that is Minto, which is up here in the Fairbanks region. We have Old Harbor down on Kodiak Island. We have Yakutat over here that has joined AVEC since I have been at AVEC. And Bethel right here is one of the hubs in the southwestern region of Alaska. It is also now an AVEC community, but it is very big compared to our other systems, which are maybe only a few hundred people living in areas you can only get to by boat or by plane. And we have been doing wind diesel hybrid for at least 20 years now. And so we have a lot to say about that. A lot of that was before my time at AVEC, but we have, so 19 of the communities are being served by wind energy. It's a lot to maintain diesel generators, which are the primary source of power in these communities. We have almost 200 diesel generators, and they're spread out all over the state. They're not all the same size. They're not all the same make. So for an organization that is less than 100 people, you can imagine we have quite a bit of work cut out for us. There's also a lot of challenges, and we've covered that a lot in these discussions already, so I don't want to spend too much time going over that. I also don't want to be the person that says, here is all the challenges. I want to come in and say, well, those challenges are there, but we are working on them and we're trying to make some progress here. So let's get the challenges out of the way. There's extreme climates, which we've talked a lot about. I saw a picture the other day from a mechanic who was working in Wales. Wales is way out here past the Nome region. And he said that the storms have gotten so bad there that even just from all the little cracks that are in the building in this older power plant, overnight there was snow inside the building. I meant to put that picture in my PowerPoint, but I forgot. So anyways, but just the extreme conditions in terms of snow drifts, you know, cold temperatures, lots of wind. So let's see, we're spread out. It's restricted transportation. So if you hear, well, you can only get there by boat or by plane, but it's more exaggerated than that because a lot of these places, the waters freeze up, and so you only have maybe a 3-month window in which you can get a boat there. And so we'll have, you know, a fuel barge that makes deliveries and is going up the river and trying to get to all the communities upriver before, in time to get back downriver before everything starts freezing again. Cost is the big one. You know, everything gets really expensive when you're working in these areas. Limited local human capacity. We've talked about that a little bit, but it can be very difficult sometimes to communicate with the people that are there on site. And you know, we have someone full-time that goes around doing training, and AEA has actually kind of copied some of that model in terms of having a person that goes from site to site training operators. And but it is, then if they leave, now what? So yeah, let's see. Well, enough with all this. Oh, I do want to touch on cyclical grant funding. That's something that we haven't really talked a lot about. Part of our conversations have been, we need to have a strategic plan. We need to sit down, look at all the possibilities, and figure out what is going to be the optimum solution for a particular community. And I have been saying the same thing for a long time, but I've realized that part of the problem is that you can figure that out, you can make a plan, but if the funding's not there, then the project's not going to happen. So then a couple years later, now there's funding, you go back to your plan, all that is outdated information because this whole industry is accelerating. So you have to requote everything, you like all your costs, all your models. It can be very difficult to keep up. And now with this most recent funding, we are very fortunate that we have received a lot of funding, but it's like drinking from a fire hose. And so I know there's a lot of concern going back to human capacity. Are there enough electricians in the state to do all the work that needs to be done that's being funded? Some of the electricians that I've talked to are saying no. So it's like, okay, well, we'll just go outside the state. Well, they're actually all booked up too. And so I want to emphasize just the need for human capacity on all levels, on technical levels, local operators, and engineers. Also, difficult to standardize between sites. So that's the other thing. I've been at AVAC for 10 years now, and it's like, okay, we're going to make them all the same. Well, by the time you start implementing a paradigm at a few places, that paradigm has shifted. And so now, and that's been happening for a long time. And so you have a wide variety of technology across 50 different power plants that you're trying to maintain. So here's a couple, I decided to try and go with pictures because they can communicate a lot and because I'm stuck with talking right after lunch. So if you see up on the upper left, we don't have bucket trucks in most of our communities. Bethel is the only community that has a bucket truck. So for linemen, they have to be extremely resourceful and cold tolerant to go out and work on lines and do what they do without some of the tools that are more standard in the industry. So so there's those challenges. I have a couple. So this picture on the bottom left is from the Stebbins wind turbine project. That turbine got installed last year and is currently running as of last fall. But this gives you some idea of these cranes aren't there normally in the community. They had to be brought in order to install the wind turbine and to be able to take the equipment off of the barge and get it to the wind turbine site. So just logistically, everything everything you do is around the barge schedule. We have to order things in the fall so that way they get built in time to be tested and shipped out in the spring so they can get to the site and done before everything starts freezing up in the winter again. So yeah, and Jennifer did a really good job also just talking about how, even within the community, you might not have great roads. You might have boardwalk. I got to go to Sellowick last year and it's nothing but boardwalk. And it was very strange driving a four-wheeler on a narrow boardwalk next to it, like 2-lane 4-wheeler. That's as wide as the boardwalk was. It was just two 4-wheelers wide. So you have to get pretty creative. And I include all this to show, like, you know, the challenges are very, very high. And so we can be, I know the temptation is for us as engineers is to be in the ivory tower. And so I've had to break past that and really engage with our field staff to learn, you know, what they're dealing with, you know, when they're on site. So climate's becoming more extreme. We talked a little bit about coastal erosion. This is a picture from Shishmaref, where coastal erosion is pretty extreme. Kivalina is another example. They have been able to build a new school 8 miles away from their current town location. But then there's all the logistics of, okay, well, how do we keep power going, you know, in between, you know, an old location and a new location, you know, and anyways, it's quite the conundrum. But community relocation can be very hard because it's both very expensive, but also because people disagree on where the new community should be. And there's a lot of people involved in those discussions. So major storms and flooding, permafrost melting. We have talked about a lot of that already, so I won't go into much depth. I will talk about foundations because that does become a lot of the costs. You know, I like to think as an electrical engineer that what I do is most important, but then when you look at a project budget and you look at civil engineering, you're like, oh, actually, they spend way more money on groundwork and everything. So, you know, having foundations that work. As another example, in Bethel, the power plant that's there now had to retrofit their foundation with active refrigeration. Because what happens with permafrost is when it's melting, now your ground is sinking. It's not solid ground. And so, you know, you start to have a building where one corner is just going down, or the whole building itself starts sinking. And so, you know, we covered this a little, you know, is it frost tracking or is it permafrost melting? Well, both happens, and there's a lot that can be involved with trying to just keep things level, and including, you know, active refrigeration, which still just blows my mind. Okay, so this slide here shows an example of a wind turbine in Tooksuk Bay. The picture on the left is when it was initially installed, I think 2007. And the picture on the right is from 2020. And is the turbine going up or is the ground going down? I'm told that the ground has been going down. The permafrost has been melting and the soil has been sinking, and they've actually had to lengthen the ground grid for this structure, which is just crazy to think about. So, you know, we talk about what's happening, but it's, I don't know, it's kind of nice to see some photos. I was in Noatak, picture on the left here. I was in Noatak when they did a fuel delivery, and unfortunately, Noatak, which is north of Kotzebue, has had the river has shifted over time, and they can no longer bring fuel in by barge, and so fuel has to be flown in to the community, and that gets crazy expensive, as you can imagine. Oh, yes, yes. So yes, there was a bad plane crash from the company that does a lot of these fuel deliveries last week in the Fairbanks area. So not only is it expensive and environmentally unfriendly, it's also has danger and safety risks associated with it. Not to mention what Nolan referred to, which is just the environmental risks of fuel delivery in general. The cost of energy there is very high. I think residentially, they were paying just for driving a four-wheeler around $16 to $17 a gallon for gasoline. And so good news is we've got some solar panels in there as of last year, and I'll cover more of that later. On the right, I'll show you. So Hooper Bay had a really rough time during the Typhoon Merbok, which hit in the fall of 2022. Storms have become more extreme, as was also talked about more recently in the presentations. But you can see there's actually a couple empty fuel tanks that have started floating, and one of them actually ended up twisted the piping, the flex piping off, and was floating on its side horizontally when it's supposed to be a vertical tank because the flooding was so bad. I was actually on call the night that storm hit, and I remember they were, all three people who knew how to operate the power plant were stuck on the other side of a flash flood, and so finally one got over there. And anyways, it was just it was really devastating, especially because there's people who live a subsistence lifestyle. They may have they may store their food in places that were compromised. That's a whole year of hunting and fishing, and that gets compromised by storms. And also, like, when power is out, it's not just the inconvenience of power being out, it's also protecting all that work that was done to subsist off the land. So the stakes for these conversations that we're having are really high. And so what has AVEC done? It's weird because a lot of what I work on is diesel generators, which is like not what we're trying to do here at this conference, right? But reliability is key. And so it's a tough place to be as a utility, wanting to integrate renewables, but also knowing that 30 years from now, whatever you do, you have to live with the consequences of that. And it's hard enough, given all those other challenges that I listed, to keep the lights on, even with diesel. So then when you start making these systems more complex, yikes. So I don't think that diesel is going away, but as I said, we've had several wind hybrid systems. We've been seeing, places where our diesels are running at their minimum load for extended periods of time. And so, at that point, that means there's so much wind that if you just had a battery, you could turn the diesel off because there's enough wind to cover the community. But you can't run the diesel at no load because it can be bad for the diesel. There's what a phenomenon called wet stacking, and that's a whole other conversation. How low can you run your diesels without causing any sort of mechanical ill effects with that? So talking to some folks from Australia, it sounds like even with PV, they don't have that bad of wet stacking problems there when they have a lot of solar battery systems. And some of the communities from the gentleman I spoke with, we personally, we've had so much, so wind is so variable that you don't necessarily end up running in a way that's so consistent that you end up with wet stacking. It's kind of like it's self-cleansing because of the variability of the wind. So we'll see how that looks as we're moving into diesel, or as we're moving into solar particularly, as well as batteries. So give me a second to drink some water. Okay, the question that came up, what does Alaska do about heat? Well, we actually do quite a bit. We've retrofitted a lot of our engines with marine manifolds and done a lot of work, especially in partnership with ANTHC, Alaska Native Tribal Health Consortium, which operates a lot of the water treatment plants in these communities. We do waste heat recovery, and so instead of just taking heat from the engine and venting it off to a radiator and now it's gone, and because you have to keep your engine cool, well, instead, if you loop it into a heat exchanger that is running a glycol loop that goes over to a community load, and they have a heat exchanger and can run their system, you can share that heat from one place to another. And so that's waste heat recovery, and that's fuel that we're already burning to keep the lights on. So that's kind of one of those win-win sort of scenarios when you can recover waste heat with fuel that's already being burned, and that saves a lot of remote water treatment plants quite a bit of money. They are more to maintain. That is the lose side of the win-win, maintaining those and, keeping all of that going and figuring out how to meter everything and doing heat sales agreements. The heat is actually sold, but it is a very reduced rate. I think it's about 30% of what they would be paying if they had burned the fuel themselves. And that helps cover the cost of the maintenance of these systems. So another bummer with diesel is that we have to have regulatory relief on our systems. We are not able to, the maintenance burden as it is already so high, and the ability to guarantee that something does not freeze is so low that it makes it very difficult to do exhaust gas treatment. And so, that's a whole other conversation, and I've had that with a couple people here, but the result is we try to find tier 2 marine engines that we can rebuild and use. And so it's kind of a mess in that sense. But the good news is, so here's some historical data regarding efficiency. So the whole goal is we have to burn diesel in these communities. We've had to for a long time. AVEC's been around for 50 years doing these microgrids. And so over time, you can see that we've gotten more and more efficient, including like adding VFDs and adding renewables. At a certain point, you can only make your diesel plant so much more efficient. And so then at a system level, getting as much kilowatt hour per gallon of diesel burned comes down to renewable integration. And so I wish I had a graph that was past 2016, but maybe next time. So we talked about Kotzebue already. You'll see in this photo, this is a photo from Kotzebue, which has also been on a very similar journey as AVEC. Kotzebue is awesome. Matt is fantastic. And they have been pretty much one of the early adopters of the technology curve and done a really good job with it. But I show this because at the smaller turbines on the right are what we started with. Wales and Selawik in particular, I know, had these turbines called AOCs. They are essentially, at least ours are not working. I'm assuming Kotzebue's aren't working either, but they were they're basically to the point where they can't be maintained. But and I think I might have my years wrong, so please don't quote me on that. But somewhere 2 decades ago, I was in middle school, and they were able to run the community of Wales diesels off back then with a giant bank of NiCad nickel cadmium batteries and these little AOC turbines. And so there's a heritage there, and unfortunately, since then it had been a long time before we were able to say, oh, we're diesels off again. But we have been at least incorporating, I don't even know how many wind turbines we have, probably somewhere in the 30s or so between all the communities, something like that. But these Northwind 100s, which is what you see on the left, those are getting pretty difficult to maintain also. There's several models, and Northwind is no longer in business. And so, you know, as a utility, you're stuck with, well, how do I maintain this piece of equipment? There's no one, there's no customer service that I can call. And so we've had to get pretty creative and found some other partners to help us with keeping those going in these communities. Another downside of those, we talk about renewables as being unstable, and part of that can just be whenever your renewable resource drops out. But also, even if you have a lot of renewable resource, just the general operation in the past has been very unstable. You know, essentially to allow for higher penetrations, my mentor, Bill, implemented a high-speed boiler control, secondary load control, in order to maintain enough frequency stability to run some of these turbines, and that is still what is running today. Fortunately, we've moved to these larger turbines. They're 900 kilowatts, and EWT, they come out of Europe, and they we have one in Bethel, one in St. Mary's, and then as of last fall, one in Stebbins. And they have the ability to pitch the blades, and that has been a game changer in terms of being able to have better control. The inverter technology is also a lot better, and so you end up just with, in general, a lot more stability. I think when the one went into St. Mary's, we may have seen as much as somewhere between 25 to 50% fuel reduction, which is huge. I wish I had those numbers off the top of my head, but it is impressive. And I've been out there when it's really windy and the turbine is going full bore and you're just running your diesel at minimum load to be there as a spinning reserve. And so the next step from having spinning reserve from a diesel, you're still burning fuel in order to use your wind power. So kind of as Bob was talking about, the thing that's really important to have at that point is energy storage. Oh, wait, we're not there yet. We're going to solar. Okay, we'll talk about solar. Solar's pretty great. So Shungnak is where this picture on the left was taken. That is not technically, it's not our array or battery, but there's been a lot of work done in partnership with the Northwest Arctic Borough to install and find a way to operate them. And so essentially, we've been able to use solar and battery in these arrangements with the Northwest Arctic Borough as essentially an IPP, an independent power producer, using a PPA, power purchase agreement. And so the first year that it was in place, it displaced almost 12% of the community's fuel usage, which is pretty insane. However, we weren't paying good enough attention to the engines and their temperatures. They were getting overcooled, and so a boiler is under assessment right now, and they do have funding to expand the PV amount. They also are going to upgrade their battery inverter to a larger size and hopefully get even more operation, especially in the shoulder seasons, because right now I've had to put in some controls to make sure that the engines are not being overcooled, and so we can go diesels off for a little while, but not for very long. But it's Alaska. Why do we have solar when it's dark so many months of the year? Surprising fact is that spring is actually peak generation, and part of that is because of the irradiance. So you have so much sunlight reflecting off of the snow that you actually make more photovoltaic power in the spring than you do in the summer, which is very interesting. I think maximum the solar guys had seen was like 1,000 watts per square meter irradiance is like maybe kind of like a really good day other places, but in the spring you might be seeing like 1,300 watts per square meter. So that kind of counteracts the whole like, well, yes, you do have to go brush off the snow. It's not that bad to go brush off the snow, right? Yeah, so there's also these particular solar panels, based on some research that had been done, are bifacial, meaning that they can actually absorb on the back, the lower side of the panel. So that allows them to maximize all of those light reflections off of the snow. And you can kind of see the angle that is needed is definitely more up than flat. So anyways, it's very interesting how they've done it. They will stagger. So there was some research done about, tracking. Should we make solar panels that move to follow the sun because it's going in circles all day in the summer? And moving parts are that's where things fail, when you have moving parts. So the answer was no, but they stagger the angle at which they're installed. So that way, this array is getting the most sun in the morning. This array is getting the most sun in the afternoon. This array is getting the most sun in the evening. So that's how you can kind of take advantage of the fact that even though the sun isn't going above you, it's going around the sky. And so just really cool stuff. Here's a graph that I took the very first spring that Shungnak was diesels off. So what is going on here? There's a lot going on. You'll see, so this orange line is the load of the village. This red line is the diesel, and it's how much load the diesel is carrying. And the green is showing you the solar PV generation. And let's see. Yellow is how much kW is being either charged or discharged from the battery system, and purple is the state of charge of the battery. So the first summer that we were operating, I think we were able to see as much as 12 hours of diesel off time in the middle of the summer, which is just so cool. Let's see. But there's some questions that come into play that we are still grappling with. And when it comes to, well, how can IEEE and all of our wonderful intelligent friends at national labs and such assist us with operating these systems, is like, okay, well, the controls for this particular PV battery are actually done by this company called Agito. You see the logo on the top left. And so the way that this whole process works is our controls, which I'm like the switchgear lady that does that, and their controls are establishing these handshakes, essentially, of saying, okay, are we ready to go diesels off? Do you have enough solar? Do you have enough state of charge? They essentially will request it, but because, we are the utility, we're responsible for, making sure that ultimately that everything is covered. And so we have to give a permissive saying, yes, we can go diesels off. And so there's this handshaking that's going on in order to allow this sort of a system to work at all. And let's see, I lost my train of thought, but yes. Okay. Oh, wow. I just have so much to say, guys. So we talked about nuclear already. The environmental risk and lifestyle subsistence stuff is pretty high. And so we don't need to keep talking about that, but I think there are some funding applications in place to at least do some studies and to do the research and talk to people about their willingness to accept nuclear as a resource, because that's the thing. You have to do the research like Jennifer does and go and ask people, go and talk to them, engage the stakeholders. Let's see, water-based energy. We are looking at wave and tidal for Yakutat. Old Harbor has been in play for some traditional hydro. The permitting process ran out of funding, but that has received funding again. So we may actually see some hydro go in, but that is an extensive, long process. Run of the river is, Igiagig has a system like that, but I think theirs has broken down and had to be replaced again. I think they're on the 3rd version now, but there's a lot of research being done at Alaska Center of Energy and Power about avoiding, trees and stuff that can come and hit the system. So I think that's coming, but we're still kind of a ways away from that being reliable. But it would be great if it were, because so many of our communities are on the Yukon River. And so if you did have a reliable river system, that would be, we have the resource, right? Okay, wow, I have so much to say. I should have timed. Okay, so energy storage, we've got batteries going into St. Mary's. That's run into issues. We do have batteries in Noatak and Shungnak. And this photo is from testing I did earlier last month with some batteries that are going into a community called Shaktoolik. And so that has wind now, but the battery will allow them to go diesels off there with that. And that already has a boiler in place. That's part of the problem with the PV sites, is that we haven't had enough heat in the plant. So, that all of that is really important, the heat especially. And it's also negatively affected the waste heat recovery customers, right? I told you we recover heat for the water plants, but then now we put in solar and now they're not getting that heat. So they're burning that fuel, even though we aren't. So it's kind of, there's a lot of pieces to consider. So I am running out of time, but I'll basically say that for technologies that have helped, we've got some startups. One named Beaded Stream made some better monitoring for the wind turbine going into Stebbins, and so hopefully we'll be able to do that. Tower top crane, that's something that will allow us to actually do maintenance on a lot of these wind turbines. And for foundations, you can see kind of on the top right here, this triadetic or multi-point foundation is something that I think we should be talking about in terms of something that, traditionally you drill a pile in to the permafrost and try to keep your building up off the ground, and that can get really expensive. But these are lower cost and they're flexible and adjustable. And so as the ground is shifting underneath the building, you can kind of adjust your foundation along with it, which I think is pretty great. So that is what some of our energy storage modules are going on to. And yeah, a lot of IoT technology is going to help enable us to have better visibility of our sites. LiDAR has been really helpful for doing more wind studies. We actually have a LiDAR unit that's going between communities to complete wind studies. And so that's something in terms of like, what are the things that are newer that are working for us? These are some of the newer things that are helping us address some of these issues that have come up in our conversations. We'll be looking at medium voltage DC intertie, we did receive funding for a pilot project for an intertie that has to be rebuilt anyways. And so it's going to be built in a way that will allow you to either do a medium voltage AC or a medium voltage DC. And the electric vehicle industry has been enabling some of this work because of all the DC-DC converters that they have just, been able, well, also just, inverters and stuff like that, in terms of being able to move around those voltages in a way that works for us, because we don't really do transmission because our systems are so small that we're distributing at 12.470 kV or 12.47 kV most of the time. But we need more people to help understand all these complex systems and troubleshoot them, because when something's not working, how do you know what's wrong? Who's to blame? That it gets very complicated very quickly. Fortunately, communications is getting better, like we talked about with satellite stuff. So being able to see what's going on at a remote site is so much easier than it used to be, even just since I've been involved for 10 years. But I think the biggest thing that I'd really like to wrap up with is I think that we need to talk about small scale thermal storage. Most of thermal storage and cogen, CHP, a lot of that is steam based, but we're not really at a scale that enables that. But there are other ways to store heat, for example, in bricks or sand. And there's been other Nordic countries that are kind of experimenting with this. But, the idea is, well, you have to burn a diesel at least at some point, potentially, in winter, if you're using PV. But, can you save that heat for later? Because I think it's really just, there's so much that storage can be used for. You have to really define, if you're doing energy storage, what is the purpose of that energy storage? Sometimes it's multiple, sometimes it's specific. Arbitrage, spinning reserve, long term. There's so many options, but even just, being able to hold on to heat and use it later instead of sending it to a radiator, I think those are the kinds of things that we need to be considering. So anyways, that's about all I have to say. Well, I mean, I probably have more to say, but that's all that I can squeeze in for right now. Thank you for listening.
So there have been 3 questions online, and I think we wanted, if you could answer those relatively quickly, that would be lovely.
Okay. Let's see. I can't quite see all of the first one. Smaller systems, trouble sourcing lower capacity. Woo, too far. So yeah. I agree that the market is moving away from small turbines. Beneficial electrification and some of the stuff that we talked about yesterday is especially another reason why you essentially, one of the lessons is, if you're going to do renewables, just oversize the renewables for many reasons. But especially because we're expecting some load growth, maybe a little bit slower of an adoption of electric technology, vehicle technology in Alaska.